Good afternoon. Today we continue solving paper 1 of British Physics Olympiad 2017, and today we have tasks G and H. So let's start from G. It's a typical thermodynamics problem. We have a radiator, water enters at temperature 1 and leaves temperature 2, and this gives energy to radiator, and we have to find a mass of steam that gives the same energy as 1 kilogram of hot water. So let's start. In this case, we know that Q1 is equal to Q2. Q1 is equal to mass of water, it's 1 kilogram, multiply specific heat capacity, this one, and multiply change of temperature, T1 minus T2. Q2 is a little bit more complex because we also have a transformation, condensation of steam, and cooling of water that was formed from this steam. So we have mL plus m S1 T3 minus T4. This temperature 100 degrees and 82 degrees. So we would better to factorize it because we have to find m. So factorize it plus C T3 minus T4. So we have that m1 S1 T1 minus T2 is equal to m L plus C1 T3 minus T4. So let's find for m is equal to m1 C1 T1 minus T2 over L plus C1 T3 minus T4. So substitute these values in calculator and you will find out that mass of steam that needed is equal to 0.0396 kilograms, or in grams it's 39.6 grams. So we solved this problem. It's actually, I would say, very easy. It's like a typical test problem. So in this case, let's solve more complex problem about electricity and circuits. So we have two circuits. First one has resistor of 2 ohms and have ampermeter that shows, and battery cell with internal resistance. So we have battery cell, resistor, let's call it R1, that have 2 ohms, and we have ampermeter that shows has negligible resistance and shows 0.80 amperes. And we also have a second circuit that also have connected 5 ohms resistors and have different value of current. It's 1 ampere. So it's also have internal resistance. We have first resistor, parallel connection, second resistor, and ampermeter, and it shows 1 ampere. So what can we do? We have to find AMF and internal resistance. So let's find what is the same. AMF depends only from battery, so it doesn't change. We can draw it. Let's recall formula. It's equal to E internal resistance plus external resistance. So for first one, it will be, because there are a series of resistors, they like connected, they just add up. E is equal to E1 R plus R1. Second case, we also they add up R and R total, but this R it's a sum of these two, like for parallel resistors. So for second circuit is equal to R plus 1 over R1 plus 1 over R2. So what now? Now we can make it equal, and we see that both have R because any other values we know it. So E1 R plus R is equal to E2 R plus 1 over 1 R1 plus 1 R2. There are quite comfortable values, 2 and 5, so it's easier to divide them in this form than to multiply it, because otherwise it can make harder to do it. So, what now? Now we put r in left part of expression, and r, and without r in other part of expression. So we have minus e2r is equal to e2 over 1 over r1 plus 1 over r2 minus e1 r. So factorize r, we get that r is equal to e2 1 over r1 plus over r2 minus e1 r1 over difference of e1 and e2. So we do it and we receive 0.86 ohm. It's our internal resistance. So what now? Now we have to find a EMF. So we use this formula. I would prefer first expression. So E is equal to E1 R plus R. It is equal to 0.80 amperes over 0.86 ohm plus 2 ohms. That is equal to 2.89 joules per coulomb, or in our case, volts. So that's it, we found. Thank you for your views.